this session we will see few problems on hypothesis testing. So, okay. So I assume that you already gone through the lecture videos of Professor Rameshwar and some of the sessions from the other TAs. Based on that, we will look into different problems on hypothesis testing, especially for that week 4 content. Can you able to see my screen, right? Can you please, someone will respond. Can you
Yes,
able
sir.
to see my screen? Okay. So we will see some problems on hypothesis testing. Yeah. See this problem number 1. Okay. So I assume that you already have some basics on hypothesis testing. Then we can proceed further. For example, the problem number 1. Okay. The university professor gave online lectures instead of face-to-face classes due to COVID-19. Later, he uploaded lectures to the cloud for students who followed the course asynchronously. That means those who did not attend the lesson but later watched the recording videos. So, however, he believes that the students who attend the class at the class time and participate in the process are more successful than synchronous, that online recorded videos. Okay. Therefore, he recorded the average grades of the students at the end of the semester. The data is given below like this. Okay. Synchronous means the students who have attended the class and participates in the process more successfully. That means physically. Okay. No, that means online lectures at that time. The next one is asynchronously means whatever the recorded videos, okay, the students did not participated in this online lecture videos. Later he uploaded those videos for other students. They watched that and they got some grades. Okay, so here you have two different grades are there. One is synchronous, another one is we are going to label it as asynchronous. Okay, so this is the average grade of those students. We have two groups. Okay, then what we will do is we try to conduct some hypothesis testing based on this problem. Okay, conduct the hypothesis testing to check whether the professors believe. He is believing that the students who attend class at the class time and participate in the process are more successful than asynchronous students. So he is believing that. Okay, so we need to check, okay, whether whatever the that hypothesis or whatever he believe, whether it is correct or not, we will check it. Okay, so the professor belief is statistically significant by using the significant level. Okay, they have given alpha value as 0.05 significant level to evaluate the null and alternative hypothesis. Before doing hypothesis testing, check the related assumptions. Okay, so we need to check the related assumptions that things is meant for this particular problem. Okay, so before that, what we will do is the assumptions are, okay, we need to observe whether this sample, okay, each sample are independent or dependent. Okay, we need to assume, okay, we need to observe this data, what kind of data it is. Okay, whether it is paired data, unpaired data. So we need to observe those things. Then we need to observe in each sample are normally distributed or it is not normally distributed. So these are my assumptions. One assumption is I am assuming that this is normally distributed data. Another assumption is, of course, it is not normally distributed data. The third assumption, you can observe it. Okay, so the observations in each sample have the same variance. Okay, so these are the some of the assumptions based on this problem statement we are going to make it. Okay, so what we will do is in Python we are trying to implement this hypothesis testing using Python code. Okay, so if you want to implement this hypothesis testing in Python, what we will do is So whatever the data they have given, so you can assume this as array data. You can use NumPy. You can store this NumPy array data in one variable. That variable is you can consider as sync. Then another variable you are going to consider as asynchronous. Okay. So now we are trying to frame that hypothesis. Okay. So the first one is our assumption is the hypothesis. See, generally these hypotheses are claims. So I'm just giving brief introduction about these hypotheses. Hypotheses are claims, and we can use these statistics to prove or disprove them. Okay, we are going to frame some hypothesis. You need to prove it whether this particular hypothesis is correct or not. Okay, you need to do, you need to prove or disprove them. So at this point, hypothesis testing factors are the problems, so that we can use this test as statistical evidence to test these claims. Whatever the claim, you need to test with the help of some statistical evidence. You need to prove it. So we can check whether your claim is valid claim or invalid claim. Okay. So what we will do is in these problems. Okay. So we need to show hypothesis testing using Python on several questions. Okay. First we will see these questions one by one. Then you can know what is this. Okay. So but before this enter into this problem, this hypothesis testing, okay, you need to know some basics of hypothesis, okay. So when you want to define hypothesis, you should understand the scientific question we are looking for an answer, okay. So you need to assume some hypothesis, for example, hypothesis H naught, okay. So you are going to assume that as null hypothesis. Then the vice versa, you are going to consider as alternative hypothesis. Generally, for null hypothesis, the symbol we are going to use it as H naught. For alternative hypothesis, we are going to use it as H1 or HA. Okay, it will be in suffix. Okay, so these two always H naught and H1 must be mutual exclusive. So that means it's not always in opposite manner, or it may be in different opposite direction. Okay, so these two data, these two for example, H naught is you are going to assume some statement, okay? So the H1 is the opposite of that assumption, okay? So for example, H naught you are going to consider as mu equal to X, okay? So that is one hypothesis. Hypothesis H naught equal to mu equal to X. Then what will happen? Hypothesis 1, okay? Mu not equal to X. That is the alternative hypothesis, or you may consider as other hypothesis. Similarly, if you are having hypothesis mu less than or equal to X, so the opposite of this, if you are assuming that hypothesis mu less than or equal to X, the opposite one is mu greater than or equal to 1. Okay. So like this, you can frame your hypothesis. Similarly, H naught mu greater than or equal to X. If you are assuming that your hypothesis is mu greater than or equal to X, then H1 will be your mu less than X. Okay. So these are your hypothesis assumptions. Then there will be some assumptions will be there based on that problem statement, or based on the statistical values given in the problem. Okay. So again, these assumptions take, okay, you need to identify, you need to decide whether it is parametric data or non-parametric data. Okay. You need to identify those things. For this, you need to select proper test. Okay. So I will show you one diagram how to select, okay, proper test, which test you are going to use, okay, which hypothesis test you want to use. Okay. So let me share my screen. It will give some. So can you able to see this picture, right? If you want to, you may note down. Okay. So this is a nice tutorial towards datascience.com. If you are having continuous data, so there are two different types of continuous data will be there. One will be paired data, another one is unpaired data. So if you are having two groups, then we can go for parametric paired t-test. Then if you are having again two groups are there, if your data is limited to two groups, okay, So we need to choose again, it is parametric test or non-parametric test. You need to choose it. So if you are having more than two groups, then again you need to check, okay, if you want to, it is parametric data or non-parametric data. If it is parametric, then you need to do analysis of variance, or you need to do, if it is non-parametric, you can apply some test, okay, Friedman test, okay. So I will show you some of the tests, okay. We have different varieties of problems based on this given data, this continuous data. We are going to select whether it is paired data or unpaired data, whether it is two groups or more than two groups, okay. So if it is unpaired data, if you are having two groups, then what we will do is we will try to, if it is parametric, then again you are going to consider as independent t-test, okay. Here paired t-test, here independent t-test, okay. So then if it is non-parametric, then you can go for man-white and key u-test, okay. So you don't worry about these tests, okay. These tests are already implemented in Python. There are existing functionalities or existing libraries are there. So if you want to use a proper test, okay, you just call that the test, okay, the test function or existing library. It will give the resultant value, okay, resultant value for your hypothesis testing or hypothesis parameters, okay. So again, if you are having more than two groups, okay, then what we will do is you can go for analysis of variance, okay. Then if you are having more than two groups unpaired data, then if you are having non-parametric thing, okay, you can choose for Kruskal's-Wallis test, okay. So we have so many variety of tests will be there. So, but all the tests will fall under these things. Continuous data, you need to check what kind of data you are having, whether it is paired data or unpaired data. Then if it is paired data, how many groups are there? You are having two groups or more than two groups. You need to identify them. So if you are having two groups, then you can identify whether it is parametric or non-parametric test. If it is parametric, then apply paired t-test. If it is non-parametric, then you can go for Wisconsin rank test. Okay, like this, you can apply. Okay, this is basic intuition behind this hypothesis testing. So the decision or the conclusion. Okay, after the performing that hypothesis testing, what you will do is you will try to obtain the p-value that will show the significance of that particular test, okay. So let me show one example so that you will get more clarity. So we have data, then I'm going to assume my hypothesis as based on this data, okay. So those who have joined now, okay, so this data is university data. One professor has took online class in the COVID time. So there are two different students are there. One is the class are attended at the time. We are going to consider them as synchronous data. Then he uploaded that video record, video lectures in some platform. That records watched by other students. That group we are going to consider them as asynchronous. Okay. So then he believes that the students will get, okay, at the end of end semester they will get some grades. Okay, like this they will get. These are their grade values. So we have two groups. Okay, then come to here. So this is assumption. Okay, hypothesis. This is null hypothesis. Initially, we are going to assume that the data is normally distributed. So this is my first hypothesis. So I'm going to assume whatever the data they have given in synchronous and asynchronous. Okay. So this data is normally distributed. Okay. So of course, if you are assuming that null hypothesis has some normally distributed data, the alternative hypothesis is reverse opposite of this one. Then in the problem statement itself, they have given alpha value. You can consider that level of significance is 0.05. Then what we will do is, if that probability value, p value is greater than that alpha value, it can be said that the data is normally distributed. So I hope you know the basics of alpha and p value. Okay, you have gone through the video lectures. Okay, so if p value is less than alpha value, what we will do is we will directly reject that particular hypothesis h naught. That is the basic thing. Okay, so if p value is greater than the alpha, okay, so you are trying to accept that one, or you can name it as fail to reject that particular hypothesis. Okay, So this p value less than alpha means you reject that H naught null hypothesis. So that is your main hypothesis. If p value is greater than alpha, then you fail to reject your hypothesis. Okay. So what we will do is come to here. So this is for this. Okay. So what we will do first initially we are going to in Python, we are trying to implement this hypothesis testing. This problem is implemented in Python. You can store them in NumPy array. We are going to have two variable data, synchronous and asynchronous data. So what you will do is you are trying to check your normality. Okay. So you are trying to take two functionalities or two functions. Okay. So I hope you know the basics of Python basics, how to define your function. Okay. So with the help of define, you can implement this normality. We can name it as check normality. So you are having some data. So this data, you can test this normality. For this, what we are doing is for checking normality, whether it is normally distributed or not. Okay. For checking this one, you are going to consider as this stats dot Shapiro. Shapiro is a kind of testing, probability testing data. If you want to, you just call this Shapiro data. It will evaluate the p-value normality. Okay. So if you want to know more about this Shapiro, you go to that docs.scipy.org Shapiro. It will give some additional data. What is that Shapiro? Okay, what it will do? Okay, basically this Shapiro will be for to test the normality. You are going to call that existing library. Shapiro will test. Okay, so this will test that null hypothesis that the data was drawn from the normal distribution. Okay, so it will check that one. So what we will do is you directly call that function. It will give that probability value. Okay, so then you can check with your alpha value, your level of significance, the alpha value is there 0.05. You can check that probability value, p value. So if your p value, after calling this one, you will get some normality value. If your p value is less than 0.05, okay. So what we will do is, so you will try to reject this null hypothesis, okay. If it is less than, so whatever the assumption you made for null hypothesis. So initially what you made, that null hypothesis, here you made your assumption as the data is normally distributed in this example. Okay. So if you are getting p value more than this level of significance value, so what you are doing is whatever the assumption you have made this h naught, okay, so it will be rejected. So it is not normally distributed data. So then what you will do after your rejection, you can try to display it is not normally distributed data. Okay, you try to print that message. So it is rejected. This is not normally distributed data. Your assumption is h naught is normally distributed data. So based on this p value you consider. Okay, so else what is there if p value is not less than 0.05. So the other case is you fail to reject this null hypothesis. Okay, so that means there is a possibility it is the data is normally distributed. Okay, so that is one assumption you can make it based on your data, based on this data. The second one is you try to check this. Okay, you are going to make some assumptions for hypothesis testing. Okay, so you try to observe your samples. Okay, whether it is having same variance or not. Okay, so for that what we are doing is again to check that variance, whether it is having same variance or different variance. Okay, so you define some function, you name it as check variance homogeneity. So basically in this problem you are having two groups of data, group 1 and group 2. So to check this variance, okay, again, okay, means this SciPy stats is having 11a function to test variance value, whether it is having same probability or not. You just call that function stats.11a. You just pass your two groups data, then it will check. Okay, you will get some p value. If it is less than 1, you reject that null hypothesis. For example, here you are going to make some assumption as the variance of sample hypothesis, the null hypothesis, you are going to consider it as the variance of samples are same. So when the case is if p value is less than 0.05, okay, so you are trying to call this function to check your assumption is correct or not. Okay, if p value is less than 0.05, you reject that null hypothesis. That means this is not same, the variance of the samples are different. Okay, so in else case it will fail. Okay, it will fail to reject it. Okay, so based on this hypothesis, I'm going to assume these two hypotheses. Based on this, okay, what you will do is again you check. Okay, so you call these functionalities by passing these values. Okay, for example, initial thing is I want to check whether my data is normally distributed or not. Okay, so for that what we are doing is you already defined this function, check normality function. Then you can pass your data, that is synchronous students data, for this normality checking. So you have assumed two assumptions. One is normally distributed data, another one is you are going to assume another hypothesis, the variance of the samples are same or not. Okay, so this is two hypothesis, you need to check this data. Okay, so initially I called my check normality. What it will do is this sync data, it will call this function, then this function, this will call this superior test. Okay, so then it will return p value. Okay, so you will get the p value. So in this example, whatever the example, this university professor example, the p value is 0.6556. That means, so you are going to check this one, 0.6556 less than 0.05. Okay, is it true? No, right? Then, so this is, it will go here. So it will fin, so it will fail to reject null hypothesis. What is your null hypothesis? Means you are assuming it as the null hypothesis as the data is normally distributed. So it is rejected means maybe there is a possibility that whatever the data they have given as, it is normally distributed data. Okay, so the data is normally distributed. So then you check this asynchronous also. Okay, you check this asynchronous data. Here you have, so you may have some doubts. Okay, when you want to call these functions. Okay, so for that what we will do is whatever the previous diagram you have seen. Okay, why you are calling this stats dot superior. Okay, so if you want to call which function you want to use, it means you go through that diagram. Okay, continuous data, paired data, unpaired data, there will be different tests will be available. So based on this, okay, this is two groups data. So for that's why we are calling the respective tests. Okay, so if you are calling this asynchronous data, so again it will give the p value as 0.0803. Okay, so again this is 0.0803. So if you check this one, so this is okay, 0.083 less than 0.005 is true? No, right? It is false. So it is failed to reject null hypothesis. So the conclusion from these two things, okay, you are getting two different values. Okay, so one assumption is whatever you have made, the data is normally distributed. That assumption is true. The another assumption you have made it as in these two cases. Okay, so this is normal distribution. The other assumptions you have going to make it as the variance. Okay, then for to check that variance, you can call the check variance homogeneity with the help of these two groups data. You can pause these two groups, you check the variance of these two groups. Okay, so then you will get the p value. That particular p value is 0.8149. Okay, so then 0.8149 is not less than that whatever the alpha value they have mentioned, 0.05. So that means it will fail. Okay, it will go for else case. Okay, it will fail to reject that null hypothesis. The variance of the samples are same. So you are going to assume that the variance of two samples are same. Okay, so these are two tests you are going to call this function. Okay, so the conclusion from this hypothesis testing. Okay, so what is the main conclusion from this hypothesis testing is you can make some decision. Okay, so at this significance level, whatever the alpha value given, okay, at this significance level alpha 0.05, there is enough evidence to conclude that the average grade of the student who follow the course synchronously is higher than the students who follow the course asynchronously. Okay, so in this example, whatever the data they have given as the data is normally distributed. Initially, you have assumed, then you have framed your hypothesis. You have done some statistical evidence with the help of some statistical tests. Okay, so the data is normally distributed, and at the same time, the variance of those values are also same. Okay, so from this, what your conclusion is? So whatever the professor he is going to assume it as, so he has assumed as some conclusion, right? So see here, the professor believes that the students who attend the class at the class time and participates in the process are more successful. Okay, so this is normalized data or normally distributed data. So all these values are higher than this asynchronous data. So we can come to conclusion that so whatever the his belief is true. Okay, so how you are going to say it as means based on this hypothesis testing you can conclude or you can make this decision. Okay, so like this you can uh, make some decisions based on this hypothesis testing. Okay, so any questions regarding this example? So you don't have any questions? If you don't have any questions, then we will move on to the next problem. So I hope you are getting some idea about when you want to use hypothesis testing or how to test this, how to prove or disprove this hypothesis testing. Okay, so based on this example, this is how we can able to prove it, this hypothesis testing. So here basically you are going to assume to check whatever the assumptions, whatever the problem statement. Okay, you are going to assume some statements based on your data. So in this example they have given this professor example, they have given two types of data. So based on this, you are going to assume. Okay, you need to check these observations. Okay, from this problem statement only, you are going to assume some data. That assumptions will be considered as that hypothesis, your hypothesis for this problem. Then you can come to conclusion based on this statistical evidence. Okay, based on these p values. Here they have given some level of significance. You can compare with your probability values with this level of significance, then you can conclude that. Okay, so again, once again I am saying, so when you are going to use or when you are going to call this particular Shapiro statistical values, or when you are going to use this 11 means, it depends on kind of data. Okay, if you want to use for to check the normality, okay, if you are having two group of data, then you can call this Shapiro function. If you are having, if you want to call variance related things, okay, then you can go for start Levin function. Okay, so if you want to learn more about these things, okay, you may refer docs.scipy.org. So to understand more about these functions, okay, I'm sending this. So I'm sharing this link. Okay, stats.shapiro, you go through that link, and I'm sharing these particular functionalities also to check the normality, because we are going to use different examples to consider same assumptions. Okay, like normality, whether the data is normally distributed or the data is having the same variance. Okay, so I'm going to post these two functions in your chart to check the normality and to check the homogeneity. Okay, so let me explain. So So based on this, we can make some conclusion as whatever the profession. Okay, this is enough evidence to conclude that the average grade of the students who follow the course synchronously is higher than the students who follow the course asynchronously. Okay, so we can make that conclusion. Okay, now what we will do is we are going to have some other test, okay, statistical test, that is ANOVA test, okay. So in which case we can go for ANOVA test, okay. We will see those next example as see this is next problem. So a pediatrician wants to see the effect of formula consumption on the average monthly weight gain of babies. For this reason, she collected data from three different groups. So the first group is exclusively breastfed children receives only breast milk. Okay. The second group is children who are fed with only formula, and the last group both formula and breastfed children. Okay. These data are like this. Okay. So you are going to have some data. This is again this is weight. Okay. Weight gain in grams. Whatever the data they have given in this problem. Okay. The pediatrician wants to. Okay. This is weight in grams. So here you have some data only breast and another data only formula. Formula means you may assume this as like uh, some bottle milk, okay, not the breast milk, okay. We are going to have some milk powder, you can mix it, okay. They have used this one. Then you have another data, both, okay, both is there. Based on these feeding values, okay. So mm, this information based on this, okay, we need to conduct this hypothesis testing to check whether there is difference the average monthly gain. Is there any difference is there on average monthly gain? We need to check it. Okay. So again we are going to consider that alpha value as basically the standard alpha value is level of significance is 0.05. If there is any significant difference, perform further analysis to find what caused the differences. Before doing hypothesis testing, check whether the related assumptions are comment on the result. Okay. So like previous example, you can consider these three different groups of data. This group of data you can consider as breast feed babies weight. You are going to store this array values into, or you can give some variable name that is only breast. So another values only formula. So like this you can store in three different arrays. Okay. Now your hypothesis. Okay. You are going to assume your hypothesis as whether this particular data is normally distributed or not normally distributed. We want to assume it. Okay. So initially I assume this as my null hypothesis is normally distributed. So of course your alternative hypothesis, like previous example, the data is not normally distributed. Okay. Then you need to check this normality. Okay. You have three different groups of data. You can call this check normality function for these individual groups of data. Okay. For example, I am calling this check normality. I am feeding these values. Okay. I am giving this only breast values. I am going to check this value. What is that my probability? If whenever you are calling this check normality, then you can pause this only breast values. Okay. It will come here. Then for this to check the normality test. Okay. You are going to use previously you used. Okay. This statistically Shapiro test function to check whether it is normally distributed data or not. Okay. You can use the same function. You will get some p-value based on your breastfeed values. Then it will check that p-value whether it is less than or more than your level of significance. In this case, you are getting your p-value as 0.4694. Then what we will do is it is failed to reject that null hypothesis. Okay. So if it is less than, it will reject it. It is failed to reject. That means the data is normally distributed. Okay. Similarly, you can call this normality. You can call this normally distributed function for these three different groups. Okay. Then what is your second assumption? Initially, my assumption is the data is normally distributed or not. The second assumption is the variance of the samples are the you need to test. Okay, this null hypothesis you are going to assume whatever the samples that are present. Okay, the variance of those samples are the same. You are going to assume that one. Once again, to call this function, you want to use this Levin function. Okay, to get your p-value, you can use that Levin function. So it will give some p-value. So in this example, based on these values, okay, you will get your p-value is 0.7673. So from this 0.7673, what we will do is it will compare that one. Again, it will fail to reject null hypothesis. That means the variance of the samples are same. Okay, that means initially your H naught, the means of all three groups of data, that means mu1, mu2, mu3, okay, are same at the same time. Okay, at least one of them is uh, now what you want to do is you want to uh, check. Okay, in the problem statement they are asking, okay, they are asking some problem. You need to check whether there is difference between the average monthly gain of these three groups using some significance. Okay, what you want to do is if there is significant difference, perform further analysis. Okay, so if there is any significant difference, we need to perform some further analysis before doing this hypothesis testing. Okay, so let me see, is there any significant difference is there or not. For that, what we will do is, so you want to do some further analysis. Okay, whether your baby's weight, okay, whether it is having different weights or same. Okay, so for that in Python, you are going to have to compare pairwise. Okay, if you are having three groups, you want to done comparison between two groups. Okay, so we have three groups. I want to do comparison between two groups. We are going to have in Python some post hoc function is there. It will be available in scikit function, I mean scikit library. So you can use that post hoc pairwise comparison. You can call that pairwise comparison with the help of these groups. Okay, so this is you can import from that function, import scikit post hocs as sp. Okay, so you can call this comparison function. Okay, so then you will get different values. Okay, it is comparing two groups of data. Okay, so from this then it will print the three different groups of data. It will give those values, comparison values here. Those groups and index values will be printed like this. Okay, so then what we are going to do is from these values, based on this comparison or based on this function results. Okay, so that the significant level we are doing some further analysis. Okay, so at this significant level we are going to conclude that only breast is different than only formula. Okay, so we can come, we are going to conclude some values. Okay, these breast values are different than only formula, or only formula is different than both breast and only formula. We are combining, or both the groups is different than only formula. Okay, so this is your conclusion. So based on this conclusion, okay, what we will do is, this is a kind of ANOVA test. Okay, we are going to select this particular there. Based on this, okay, we can conclude that at least one of these groups has a different average monthly weight. So it will give these some different values, right? Based on this, we are going to conclude that, for example, see here, so there is some different average value is there from this post hoc comparison. So based on this, there are some values are different. Okay, so based on this, we can conclude that, so at least one of the groups have a different average monthly weight gain. Okay, so Like this we can make some conclusions based on this post-hoc. Okay, this is a kind of ANOVA test. So this is one of the problem we can solve by using hypothesis testing. Okay, so let me share this codes also. So in the first example, you have seen only you are going to have group data, two groups you have. Now in the second example, you are going to have three groups data. Okay. So if you are having two groups data, you can identify whether it is normally distributed data or not. If you are having three groups data, what you want to do is you want to perform some comparisons among your groups. Okay. So for that, I initially showed some diagram, okay, in which case you are going for which kind of test, okay. So in that diagram, okay, so you are going to have, if you are having two groups, then if it is having paired data, two groups that you can go for parametric or non-parametric, okay. So if it is having unpaired data, then you are having more than two groups, okay. Based on it, you may have different kinds of tests will be there, okay. So that is the conclusion we can make from this. So is there any questions? So if you don't have any questions, then I will discuss about the next problem regarding this hypothesis testing. Let me, you can take some 2-3 minutes time to identify this problem statement, okay, this problem 3, okay. So this problem 3, a human resource specialist working in a technology company is interested in the overwork time of different teams to investigate whether there is a difference between overtime of the software development team and the test team. She selected 17 employees randomly in each of the two teams and recorded their weekly average overwork time in the terms in hours. Okay, the data is in terms of hours. The data is below. That is, one is test team, another one is a software team. Okay, so this is their working hours. Whether we need to test it is over. Let's the employees are working in overtime in software development team, or the employees are working in test team. Okay, these are two different kinds of data. According to this information, conduct the hypothesis testing to check whether there is a difference between the overwork time of two teams by using the same, okay, the same level of alpha significance value. Before doing hypothesis, okay, you can check some, is there any related assumptions are there, okay. So you just take some time to analyze the problem statement, and you can frame your hypothesis based on this data. To take some 5 minutes time to analyze this problem statement and how you can able to assume your hypothesis H0 and H1 data. Then how you can check whether this particular team data is normally distributed or not, okay, or you are going to assume that the variance of both the groups are same or not, okay. You check this one. If anyone is interested, I already gave the to check normality, I gave the code in chat box. You can use that code and you can implement, you can use that check normality function and check variance function. You call those functions and you can compute that p-value. Then you compare your p-value with level of significance. Then you can make some conclusion based on this problem. Okay, you take some 5 minutes time to analyze and to compute the p-values. Okay, it is more of like the problem one, whatever you have seen. It's like two groups data. You just analyze like that. Okay. See, from this example, yeah, well, let me explain this example. So, like previous example, this example is a human resource specialist working in different technology company is interested in overtime of two different teams. There are two different teams out there. He is interested in overwork time. Okay, to investigate whether there is a difference between overtime of software developed team and the test team. He selected different employees randomly in each of the two teams and recorded their weekly average work time in terms of an hours. Okay, this is weekly average time. What we will do is here you have two groups testimony software. Like the first problem, you store these array values into these teams. Then you can assume, okay, initially your hypothesis will be, so in this example, the hypothesis is you have two teams, so that you are going to assume it as the average time. Okay, the average work time mu one in one team. Okay, this is mu two. Okay, you can assume that. Okay, So initially I am going to assume that mu1 less than or equal to mu2. So that is your hypothesis. You are going to define your hypothesis mu1, that is average of one team. Mu1 is average mean of one team less than or equal to average mean of other team. Mu1 less than or equal to mu2. That is my null hypothesis. So the another, of course, the alternative hypothesis, the opposite, mu1 greater than or equal to 2. Okay. So in such cases, what you will do is you can check. Okay. You can call that normality function for these two teams. This is my test team and the developer team. It will give some p-value. This is my p-value. Okay. I think I no need to explain. Okay. Again that normality. So I will get some p-value here in this example. So I'm going to get my p-value as 0.0046. Okay. So my level of significance they have given as 0.005. Okay. So what it will do? P less than alpha. In this case, so this p less than this p-value is less than, so alpha, that is level of significance 0.05. So you are trying to reject that hypothesis, whatever the hypothesis you are going to make it as. You are going to your assumption as that hypothesis. How you are defining is like in this problem mu1 less than or equal to mu2. Mu1 is the average work time of one team, mu2 is the average work time of another team. Okay, so that is your null hypothesis you are going to admit. So this is directly it is rejecting. Okay, this based on this p value you can reject that null hypothesis. This data is not normally distributed. So similarly, you can check for developer team also. This is also again 0.005, that is less than 0.05. This is also it will reject whatever the null hypothesis you have made. That will be rejected. Okay. So in this example, in the first example, the data is normally distributed. So in this case, the data is not normally distributed. Okay. Now come to here, your second assumption, the sample variances. You need to check whether the variance of the same variance of the given data is same or not. In this example, the variance of these samples are same or not. Okay. So then you check this variance. You call that check variance homogeneity. What we'll do in this case, the p-value is 0.51, I mean 5410. So it is going to fail that. That means this is okay, not less than alpha. So it is greater than, the p-value is greater than alpha. So it will comes under else what, fail to reject your null hypothesis. So the variance of the samples are same. Okay. So whatever the data here they have given, there are two assumptions we can, okay, two conclusions we can came. Okay, one conclusion is whatever the data they have given as, the data is not normally distributed. The second one is the variance of the samples are same. Okay, so that is two conclusions we can made from this p-value or from this hypothesis testing. Then what we will do is we try to use, okay, whenever you are having such cases, okay, this is kind of two-sided data, so you can go for some other further analysis. You can use some other hypothesis testing functions, that is man white new function. You can, for further analysis, you can call this function. Okay, whenever you are having same normalized distributed data, I mean different normalized distributed data and same variance values, you can call this one. Okay, then you will get some p-value. Again, this will be available in scikit library. You can call this function directly. Okay, so for this kind of problems, you can use man whitening u function. Okay, then where you will get some p-value. My p-value is 0.822. This will be the greater than the level of significance. Then it will fail to reject that null hypothesis. Okay, so the conclusion we can made from this man whitening function as, so the conclusion is, so there is no statistical significant difference between average work time of the two teams. Okay, so the conclusion is there is no difference between those teams. Okay, even software team and test team, there is no more difference in that average overwork time of that two teams. Okay, so from this hypothesis testing, we can make that conclusion. Okay, so here, whenever you are getting two groups data, okay, for example, in this example, how to select the proper test, okay, why you are selecting man white knee, okay. So whenever you are having these two groups data, one data is collected from different individuals, it is not paired data, okay. So however, the normality assumption is not satisfied in this example. That means the data given as it is not normally distributed. Then what we will do is we need to use some model, okay, that is non-parametric version of two groups comparison, okay. So we can go for some unpaired data. So that unpaired data, uh, for unpaired data, the proper test will be the most famous test is man whitney U test. You call that function, then you will get your p value, then you can make your conclusion, okay. So like this, you are going to have different examples. So the another problem, okay. So any questions? So the next problem, so you are going to have the next problem as you just study this problem, okay. The next problem, an e-commerce company regularly advertises on YouTube, Instagram, and Facebook for its campaigns. However, the new manager was curious about if there was any difference between the number of customers attracted by these platforms. Therefore, she started to use Adjust, an application that allows you to find out where your users come from. The daily numbers reported from Adjust to each platform are as below. Okay, so there will be one e-commerce company is there. The company wants to give some regular advertisements for three different platforms for campaigns. Okay, like YouTube and Instagram or Facebook are three different platforms. So you are going to have some data, okay, in each and every platform. Let us assume that this data is number of customers attracted for this platform, YouTube, this many number of customers, okay, like this, you are going to have some data for a specific time, okay. So according to this information, we need to conduct a hypothesis test to check whether there is a difference between the average customer acquisitions of these platforms using this level of significance, the same level of significance. You need to check, okay, if they are using YouTube, how many number of or how many customers are attracted uh, from that advertisement from the YouTube, or if you are posting that company advertisement on Instagram, based on that impact or based on these Instagram advertisements for that particular company, how many customers are acquisited or attracted to that particular company. Okay, you need to analyze. Or if you are posting some advertisement on Facebook, okay, so you need to analyze this data. Okay, for that the same example, the implementation in Python is same. Only the examples or the problems have different groups or different platforms and different values, okay, different numerical values. So here also what we are doing is we are trying to read this data in numerical pi array. You name it as same name YouTube, Instagram, and Facebook. Then you can make your assumptions, okay, like the data is normally distributed data, you want to analyze your null hypothesis. So in this example, you need to, you can make, okay, based on this problem statement, initially your hypothesis, you assume that you want to define your hypothesis for this problem statement. Your null hypothesis is mu1 is your, you assume that mu1 is your YouTube mean values, mu2 is your Instagram mean value, then mu3 is your Facebook. Okay, so your null hypothesis is you are going to check the mean values of the sample as same. Initially, you are going to assume your null hypothesis as mean values of your hypothesis are same. Of course, the next alternative hypothesis, okay, H1 is at least one of them is different, okay. So then you check the particular data, whatever the data they have given as normally distributed or not normally distributed. Then you check the variance values, okay. Then you can select appropriate test, okay. Like previous examples, I am going to check my normality by pausing these YouTube customers, okay. Then you will get some p-value. So this p-value is not less than the alpha. Then you can, of course, yeah, this p-value is 0.0285. So it is less than 0.05. You reject your null hypothesis. That is, the data is not normally distributed. So whatever the data they have given in YouTube, okay, the customer's data, this data is not normally distributed based on this check normality function, okay. Whenever you are calling, you will get some p-value. It is not normally distributed, okay. Then you can check this thing also, okay. Then this is also 0.415, okay. Your p-value is 0.5415. So it is having more than your level of significance, then it will fail to reject your null hypothesis. This data is normally distributed. So this second Instagram and Facebook data is normally distributed. Only the first one is not normally distributed, okay. So this hypothesis you check. Then come to the next hypothesis, that is the variance of the samples are same or the variance of the samples are different, okay. So for this again you call that check normality variance function, okay, check variance function. So you will get some p-value. In this example, you are going to pause all these three platforms data. Then to check the variance, you are going to use as a Levin function. It will give some p-value 0.0012. Then you can, okay, this is less than your null hypothesis. Then you reject your null hypothesis. Okay, that means the variance of the samples are different. Okay, so for example, whenever you are having such scenarios, okay, so the variance of these samples are different. What we will do is you need to select the proper test. Okay, so the normality and variance of homogeneity as the assumptions are not satisfied. Okay, initially the normality, that means the normality is different for the first platform. So whenever you are having this kind of cases, the normality and variance are different, okay, in this example. What you will do is you can prepare, okay, you need to select that proper test. We need to use non-parametric version of ANOVA test, okay, for unpaired data. So for that, you are going to have, there is some Kruskal test is there, non-parametric version of ANOVA for unpaired data. The data is collected from different sources. Okay, you are going to collect the data is from different sources. In such cases, you are going to call that Kruskal function. Okay, so it will give this p-value. So that p-value is 0.05. So in this example, if you are calling these values, you will get the p-value as 0.00015. So that means it is less than this value, then you can accept this hypothesis, whatever the hypothesis you are going to make. So what is your null hypothesis you are going to make it as? This mean of these samples, okay, mu1, mu2, mu3 are same. So the conclusion is, so the average customers, the conclusion, so it is rejected. Initially, you are going to assume the average number of customers on these three platforms, mu1 and mu2, mu3 are three different platforms. You are going to assume this as your hypothesis. So this based on this Kruskals, this is going to reject your null hypothesis. Whatever the hypothesis you are going to assume that, it is going to reject it. Then what is that? At least one of them, one of the platform is having a different acquisition of customers. Okay, so even based on observation of this data, so you may assume that this is having, okay, that more acquisition of customers. Instagram platform is having more acquisition, but whenever you are having such kind of data, okay, you cannot come to conclusion. This is small sample data, right? In real time, what will happen is you are going to get more samples and more data. Okay, in such cases you can't make your conclusions based on observation. Okay, you need to apply or you need to perform your hypothesis testing. So from that you are going to prove or disprove some statistical evidences. From that only you are going to conclude. Okay, so in this example, initially they are going to assume that all these platforms having same my hypothesis. Okay, my hypothesis is I'm going to assume these three platforms. Okay, I'm going to assume as this is mu1 data, mu2 data, mu3 data, all these same platforms having equal number of acquisition of customers. Okay, my that is my hypothesis. Then we are going to have some assumptions. Based on these assumptions on data, so initially I got some different normal distributed data for one platform, and variance also I'm getting some different things. Whenever we are having not satisfied, okay, the normality and variances, then you can select the proper test. Okay, so how you are going to select your proper test means, initially I showed one figure. Okay, if you want, I will copy that figure and copy image. So initially you have seen some image. Based on that image, we are selecting the proper test. Okay, so in this example, the hypothesis test. Okay, we have selected as, for this example, the variation in ANOVA model, that is Kruskal. Kruskal values. Kruskal values is the particular test we have selected. Okay, so the conclusion is at least one of the average customers acquisition number is different. Okay, in one group. Okay, since the data is not normal and the non-parametric version of this test. Okay, so that is the conclusion from this test. Okay, then come to the next example. Just go through this fifth example. If please go through the next problem, and based on this problem statement, you can formulate your hypothesis. Then you can prove and disprove your hypothesis testing. So in this example, the next problem statement. So what they have given as there is some university healthcare center diagnosed 18 students, with high cholesterol in the previous semester. Okay, healthcare personnel told these patients about the danger of high cholesterol and prescribed a diet program. Okay, 1 month later, the patients came for control, and their cholesterol level was re-examined. Test whether there is a difference in the cholesterol levels of the patients. We need to test. Okay, according to this information, conduct hypothesis testing to check whether there is a decrease in the cholesterol levels of the patients after diet by using 0.05 significant level. Before doing hypothesis testing, you may assume something. Okay, so you are going to have two data based on the information in the given problem statement. These are the test results before diet. Before diet, they have the cholesterol. These are the cholesterol values. Okay, so this is after diet. They have some different cholesterol values. Okay, for 18 students. Okay, they are having 18 students. So this is a kind of data which is having continuous data at the same time. It is having a kind of dependent variable. Okay, it must be a continuous value. Okay, for example, the data is same. Okay, only one student you are checking before diet and after diet. Okay, this is a kind of dependent variable. So this is one of the assumptions. This is a kind of continuous or some kind of interval data. The next assumption is the observations are independent of one another. Okay, we are trying to make another assumption. This person cholesterol and another person cholesterol is different. Then the third observation, third assumption is we are going to make it as the dependent variable should be approximately normal distributed. Okay, so this is also similarly you can check. Okay, these are my assumptions. So what is your hypothesis? You can assume that your hypothesis, you need to define your hypothesis, right? That is mu is h naught. Okay, h naught equal to mu d, diet of that particular group. Okay, is greater than 0. That means the two mean differences is equal to or greater than 0. Of course, my alternative hypothesis, I am going to assume my hypothesis as diet of mean diet is greater than 0. Okay, I am going to assume that is my null hypothesis. Okay, so greater than or equal to 0. Of course, the alternative hypothesis diet is 0. We are going to assume like that. So initially we can check the normality. Okay, whether the particular given data is normally distributed or not. Okay, like the previous examples, you call this normality function for these two before diet and after diet. You may get the p-value. Then you can check or you can compare this p-value with your level of significance. So I'm going to get my p-value as 0.1635, and in this case, okay, whenever this test results before diet you are passing means your p-value is this. So this is not less than 0.05, then it will fail to reject your null hypothesis. What is your null hypothesis? My null hypothesis, I am going to assume it as the diet mean of that particular diet is greater than or equal to 0. Okay, so this is the data is normally distributed. Then similarly for after diet also the data is normally distributed. Okay, this is my hypothesis. Okay, so you can assume your hypothesis like this: the diet is greater than or equal to 0, and diet is the alternative hypothesis 0. Okay, then what you will do is, so in this example you can it is a dependent variable. Okay, you no need to go for variance and all. Okay, so because you are having a dependent variable, there is no need of variance assumption. Okay, so it is having only one variable, a specified interval time. You are getting only one range values. So then there will be no need. You just check the normality. The data is normally distributed or not. The next one is you can call the respective function if you are having this kind of data. Okay, so you can go for t-test independent. Okay, there may be proper test. Okay, this data is collected from the same individuals and the assumptions are satisfied. Okay, then we can use the dependent t-test. Okay, to test these values. Where if you want to select a proper test, okay, this is the kind of data, same individuals and the assumptions are satisfied, you can use the dependent t-test. So for that dependent t-test, okay, there is t-test underscore related, there is some t-test is there in scikit. You call that function, you pass your before diet values and after diet values for this function, you will get your p-value. Okay, so it is paired data. Why means paired means only you are getting for one individuals you are having one value, for another individuals you are having for after some time you are going to have some another value. Okay, so this is kind of paired data, so you can use paired test. Okay, so for that you want to choose p-test relay, then it will give that paired p-value which will be the less than this level of significance value. So you check what is your p-value. I am getting the p-value from this. Okay, so you are going to get p-value as 0.08. Okay, if you are having paired data, then you may go for by 2, or if it is having any paired data, you can apply pi 2. Okay, so even though this and okay, this is one tailed. Okay, this is having one tail data, this is having two tail data, even though this is itself it will reject null hypothesis. Okay, so if this p value is less than 0.05, then it is rejecting this null hypothesis. What does that meaning is, your null hypothesis you are going to assume that as your diet value is greater than or equal to 0. So the conclusion from this statistical or hypothesis testing is, there is enough evidence to conclude that mean cholesterol level of patients has decreased. So you are going to assume your hypothesis has increased. So, but it is rejected here. Okay, so that's why it is rejected after diet. Okay, so this statement is rejected. Of course, the diet cholesterol is decreased after diet. Okay, so this is how we can test or we can come to conclusion. You can prove your hypothesis based on these hypothesis tests. So any questions? Is that clear? So I'm explaining, I'm just giving these codes. It will be there in my drive. Okay, so you need to understand or you need to frame your hypothesis. Then after that only, if there is any assumptions, you can make your assumptions. Then you can apply appropriate test for your statistical evidence. Then you can make conclusions based on your statistical evidences or based on your p values and your level of significances. You can come to some conclusion. Okay, so we will see some another problem. If you are having any questions, you may ask questions. Otherwise, I will move to the next question. The next problem is, you just go through this problem statement. You take 2 minutes time, go through this problem statement. So all these problems I took it from some tutorial towards data science. I'm sharing this link also in chat. These are some good problems. I felt it will give some more clarity about hypothesis testing. It will give more idea to understand a variety of problems and which how to do your how to prove for hypothesis testing. Okay, so this is a good resource. I felt that this resource is good. That's why I'm discussing these problems here. Okay, the next problem is there is a venture capitalist wanted to invest in a startup that provides data compression without any loss in quality, but there are two competitors. One is Pied Piper and another one is Enframe. Initially, she believed that uh, performance of the Enframe could be better, but still wanted to test it before the investment. Okay, so there are in this example there are two venture capitalists are there. Okay, so one person want to invest in startup. Okay, so initially they are going to believe. Okay, N frame could be better, but still wanted to test before they are going to invest it. Uh, they want to test whether it is giving a better performance or not. Okay, so the data is there, Pied Piper and N-frame. According to this information, conduct the related hypothesis testing by using that level of significance. Okay, before doing this hypothesis testing, check is there any assumptions we can able to frame this or from this problem statement. Okay, then we can comment that results. Okay, so again, this kind of problems, okay, this is a kind of dependent variable problems, okay. So the observations are independent from one another. These two are two different, they are not dependent. This is different company data and this is different company, they are independent from one another. The dependent variable should be approximately normally distributed, okay. So let me come to here, okay. You can call your normality function to check the given data from two different companies, which is whether it is normally distributed or not. You just call that normality function uh, from this from the given data. Then you will get your p-value. Your p-value is 0.0304. Okay. First, initially you can assume, okay, this is your hypothesis. So you are going to frame your hypothesis as I am defining my hypothesis. I want to check. Okay, so the performance scores are obtained from the same files. Okay, the data is paid. Okay, initially you can assume that mean of the particular data, whatever the data is greater than 0, that is my null hypothesis. So the mean of that particular data, the given data is greater than 0. That is my hypothesis. Initially I am going to assume. Then I am comparing. Okay. So whenever you are having this kind of data, for example, in this case, this company data is not normally distributed and this end frame company data is normally distributed. Okay. So you are having two different companies data. One company data is not normally distributed. Another company is normally distributed. Okay. So then what you will do if you are having such situations? Okay. So for this, there is if you want to select a proper test, okay, so you need to select non-parametric version of paired test. Okay, so namely this will will Wilkerson signed rank is one of the test. Okay, Wilkerson signed rank test is the one of the test whenever you are having one kind of data is normally distributed, another kind of another data is not normally distributed. You can go for further analysis. You can go for this Wilkerson signed rank. You call that function from scikit-learn. So you are having two different values, right? So then you will get p values So initially you will get your p-value, then you will get one-tiled p-value. Okay. So if you are having initial value 0.00 some value, so this is one side value. See, from this p-value we can come to conclusion. Okay. So this is less than your level of significance, that is alpha value. From this, whatever the hypothesis you are going to assume, okay, that is rejected. Okay. So based on that, this rejected, that means at this particular, okay, at this it is rejecting this particular hypothesis, reject h naught at the significant level. There is enough evidence to conclude that the performance of pied paper is better than the end frame. Okay. So if you want to give compare two different companies, you may go for this thing, then this rank. Okay, you need to give some rank to one company. Okay, so then it will test this particular hypothesis. So if it is rejecting, then we can conclude that the Piper data is having better performance than the in frame. Okay, so this is the conclusion from this problem statement. Okay, the next one is we will see another problem. So a researcher was curious about whether there is a difference between the methodology she developed, C, and baseline methods A and B. In terms of, okay, there are some experiments are there. Okay, in terms of performance. Therefore, she decided to design different experiments and recorded the achieved accuracy by each method. The below table shows the achieved accuracy and tests by each method. Please note that the same train and test sets were used for each method. Okay, so these are the I think the different accuracies for different methods. They are having the researchers having different experiments for each and every individual experiment. They are having different accuracies for different methods. Okay, she developed C. Then she is comparing these accuracies with existing or the baseline methods A and B. Based on these accuracies, we can come to conclusion. Okay, according to this information, we conduct the hypothesis testing to check whether there is a difference between the performance of the methods. The same thing. Okay, if there is any significant differences, perform further analysis to find which one caused the differences. Okay, before doing this is similar only. Like previous example, what we will do is we need to take this data into three different numerical numpy arrays, method A, method B, method C. Then you can call that normality function. You check whether this data is normally distributed or not. Okay. So initially method A, method B, you are getting the p values are 0.0307. This is not less than level of significance, then it will fail to reject your hypothesis. Then the first A data is normally distributed. Similarly, for method B also it is normally distributed. Then when it comes to third method C, the data is normally distributed. Okay, whatever the data we are getting, it is normally distributed. Okay, then in these cases, okay, then you can check the variance of these samples. Okay, these are three different groups of data. That's why we are going for variance checking. Okay, so again, like previous example, to test a particular problem having same kind of variances, okay, the samples having same variance or different variances, you call this stats.levin function. You can check. Okay, you get some p-value. This p-value is 0.015. This is less than, no, it's not less than, then it will go for else statement. It will fail to reject that particular null hypothesis. Okay, so the variance of these samples are same. Okay, so what is this conclusion is, so if you are having like this, okay, the variance of these samples are same, and you are having two baseline methods having normal distributed, and your own method is having a different distribution. Okay, so then in such cases you need to select a proper test, right? There are three groups are there, but the normality assumption is violated. Whatever the assumption you have made, it is violated for method C. So we need to use the non-parametric version of ANOVA for paired data since the accuracy scores are obtained from the same test sets. Okay. So what we will do is you can call this is having okay. This is another uh, fried man chi-square. We are trying to call chi-square test whenever you are having such kind of assumptions. The variance of the samples are same. Then you can call this Friedman chi-square test. Okay, you will get p-value if your p-value is less than uh, okay, less than this 0.05. Okay, so in this case we are getting the p-value as 0.015. So it is rejecting the null hypothesis. Okay, so that means the conclusion is, so if you want to make some conclusion, we need to go for some further analysis. You may take the further analysis. We can call the previously you are calling some ANOVA, right? That you can call the same function. Okay, then you can made if you are having these three groups, you can made some conclusion. Okay, based on these functional values. So method C is outperformed others and achieved better accuracy scores than the others. Okay, so that's how we can do some further analysis. See why we need to compare at least one of the methods have different performance or not. Okay, whenever you are having there will be different methods. Since the data is not normal and non-parametric, okay, you can go for post hoc testing. This post hoc testing is will compare groups, then it will give some different values for each and every group. Based on this, we can conclude that this method C outperformed others and achieved better accuracy scores than the others. Okay, so this is the how we can able to conclude. Okay, so the another example is, so there is, you just take 1 minute time to read out this problem, then we will discuss the last problem for today's session. So let me go through this problem. The next problem. An analyst of financial investment company is curious about the relationship between gender and risk appetite. A random sample was taken of 660 customers from the database. The customer in the sample were classified according to the gender and their risk appetite. The result is given in the following table. So we are going to have the gender is here, okay. So and some random samples they are taking very low, low and medium, okay, high, very high, okay. Like this, you are going to have test the hypothesis that the risk appetite of the customer in this company is independent. Okay, they have given the level of significance alpha is 0 or 0.01. Previously, they have given the level of significance is 0.05. Okay, So what you will do is you can consider the hypothesis as your hypothesis as, so the first your null hypothesis is gender and risk appetite are independent. So this gender and there is no relation between these two things, gender and risk appetite. These are I'm going to define my hypothesis as like this. Okay, gender and risk appetite is independent. Then of course the alternative hypothesis will be gender and risk appetite are dependent. Okay, so initially my null hypothesis I'm going to define as independent. So the alternative one, of course, it will be gender and risk appetite are dependent. Okay. So for this kind of problems, we can use chi-square test should be used for this question. Okay. So this is to test. Okay, goodness like some goodness of it. So you are having values, right? For example, if you take, okay, from observation, you are having two different values. For example, for female. For gender female, okay, you are having two different values. You are going to give that, take that observation. That means that is one sample. Then that observations, you can use this chi-square contingency from the existing circuit. Okay, so you can check that freedom. I think you know the basics of this chi-square test. Okay, you will get some degree of freedom and these p-values and test stats. Okay, so similarly, you can calculate for, you need to check. Okay, they have given the some alpha values. Okay, so you can take that alpha value, you apply into chi-square test. Okay, so based on this, okay, based on this basically we can choose chi-square test to solve this kind of problems. From this, okay, from this what we will do is the conclusion is the p-value is we will get the greater than the level of significance value. Okay, after calculation of this p-value, we are going to get is greater than. Okay, that means more than this 0.13 is more than the 0.01. So then we can conclude that based on these values, we can able to reject. Okay, null hypothesis. Okay, then this gender and risk appetite. Okay, what will happen is this p-value is larger than this particular alpha. So the conclusion is from this hypothesis, the gender and risk appetite are independent. Okay, so for this problem, whatever the assumptions we have made, okay, so it may be independent. Okay, you will get to go through this chi-square test. Okay, you will get a more detailed understanding about this problem statement. Okay, so with these examples from the hypothesis testing, I am going to conclude this session. If you are having any questions or general questions, you may ask now. So these materials are there in my drive. You can able to access these codes and materials, or you go through that link. Okay, this nice tutorial from towards data science. Go through that tutorial uh, to get some understanding about how to formulate hypothesis testing and how to define your hypothesis testing and how to prove and disprove your problems based on your level of significance. And there may be different kinds of tests are there. Okay, whether it is, if you are having continuous data, you are going to have paired and unpaired data, or see, mostly the major problem to prove this hypothesis testing is the selection of appropriate test. Okay, so this appropriate test, okay, plays vital role. These appropriate tests will be two types, paid and unpaid. If it is paid, again you can check whether it is two groups data or it is having more than two groups. So if it is two group data, then each and every group, okay, again we are going to classify whether it is parametric test or non-parametric test. Okay, you need to find out that appropriate test, and only we can uh, apply appropriate tests. Okay, so with this, I can conclude my session. Any questions? Any general questions or any other questions you may ask now? Otherwise, I will end this session. Okay. I hope there will be no questions. Thank you so much, all. Good night.